Okay, so the black line on, not this side, there's no black line on this side, but on this side there's a black line that goes around the edge. You're going to cut along that line. Okay? Okay, so once you cut it out, you're then going to fold these tabs over, like so. Probably going to be a little off in terms of those lines, but that's okay. And I recommend doing this first before cutting the individual tabs. And then what you're going to do from there. You're then going to take a pair of scissors again, and you're going to cut that line, that line, that line, and this line, this line, this line, and this line. And then you'll have a nice little booklet. I'm not going to cut mine because I want to keep mine for records. So mine's going to stay like this. And it's easy for me to work with and write on. All right. However, I'll give the pair of scissors back over to here. All right, now you have a nice little study booklet. So, you see a bunch of stuff and things on here. So, these are basically the triangle congruence theorems, okay? Every single one of these we have side, 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 angle, side, angle, 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 side. Yes, I know what that actually, yes. Angle, angle, side, side, angle, hypotenuse leg, and side angle side. All right? Notice there is no such thing as side side angle. Don't even try and use it. Doesn't exist. Right now, in all intents and purposes, it does not exist for you guys. Okay? So, why do we need to know these? Well, we need to know these because it's going to help us prove all of these guys. These guys will help us prove that two triangles are congruent. So long as these three parts of two triangles are congruent, the two triangles are related regardless of size. Okay? Or at least regardless of scale, I guess is a better way to put that. Okay, so first thing you need to write up here is you only need 3 sets of corresponding parts congruent in order to prove two triangles are congruent. Are congruent. Okay? And the big question you have to ask yourself is, do you have the correct information to do so? Okay? That's the big question you have to ask yourself every time you look at one of these kinds of triangles. Okay? So, the first one we're going to look at, and I will go down this way and then the other column, primarily so that way I can keep this up here for people who do writing, is the first one here, which is two pairs of congruent sides and, with an ampersand, the included angle. This is what we classify as the SAS congruent postulate. Okay? Why it's called side angle side. SAS. Or SAS. For short. And it is indeed yes. Why yes? It is definitely congruent. Two congruent sides, angles. We're good to go. All right? Now, The other one, next one down, is the hypotenuse legs theorem, which states that you have two pairs of congruent sides of a right triangle. And I want you to underline that. And I left my red pen over there. Darn it, I'll do it in pink. A right triangle. This means that the hypotenuse leg theorem only works with right triangles. Do not try and use it on anything else. Unless they put that little tiny box in the corner, don't try and use it. This is what we classify as the HL congruent postulate. This one you actually won't see very often, surprisingly. And again, that is YES. It is definitely congruent. Congruent sides, angles are the same. All right? So far, so good? Nobody confused? Everybody's figuring out, right? Okay. And the last one in this column. Triangles may not be congruent. Okay? That is a big NO for this one. Why? All right, so let's take a look here. This side and this side, right? These two angles, are these angles the same? If we try and look at it. Are these triangles the same at all? Let's just jump right to that point. Are they the same? Yep, take that sheet right there. Yep. And then just cut it out. You're fine. All right. So that takes care of that column. I'll leave that up here for a second. Okay, so let's look at the other column. This is probably the easiest one to recognize, right? And the reason why is because it has the same letter for every single one of its acronyms. This is the three pairs of congruent sides. I'm going to rewrite that word because I wrote it really bad. Congruent sides. Or what we like to call the SSS postulate. Yes, it is definitely congruent. Okay? Congruent, congruent, congruent. Okay? The next one down is the ASA, congruent postulate, which is two pairs of congruent angles and the included side. Sorry. I said side? Side. side, or the ASA congruent postulate. And that is a big YES as well. Okay? They're congruent. Yep. Checks out. Okay? And finally, or at least, sorry, not finally, two more, sorry. This one right here, which is the two pairs. This is the angle side. Two pairs of congruent angles and the non-included side. Okay, so let's talk about what the heck it means by included. What it's talking about when it says that is it's saying if it's between the two congruent parts or if it's outside the two congruent parts. That's all that's saying. Okay? Angle, side, right? Angle, side, angle. That's the only difference. Okay? The included side. Okay, and this is what we classify as the angle, side congruent postulate. And yes, it is congruent. Finally, this one right here. If the angles are all the same, but the size is different, this comes back to that scaling question here. Are they congruent? No, they're not. You cannot prove congruency on just the angles alone, because a shape can be scaled up or down, as we saw in transformations, and the angles can stay the same, right? That doesn't necessarily mean that's isometric. So you have to be careful. So we cannot prove congruent, but the triangles may be similar. Okay? No. Okay? So again, yes, they're similar triangles, but they're not congruent because the sides aren't. Now, going back to this one real quick, I want to mention something. There is no such thing as a postulate that is side-side angle. Don't even try and use it.